Hello बच्चों, how are you? I hope that you all are good. In this video, we'll solve the IIT-JEE PYQ that was asked in 2013, and this is very important question related to the Newton's laws of motion and friction. So, in this unit, we'll solve this problem. So, let's read the problem. The two blocks of mass m1 is equal to 20 kg and mass m2 is equal to 12 kg are connected by a metal rod of mass 8 kg. So metal rod is there of 8 kg. The system is pulled vertically up by applying a force of 480 Newton as shown in this figure. The tension at the midpoint of the rod is. What is the tension at the midpoint of this rod? Let this is O. So, बच्चों, in this question, if I tell you that there is no mention of gravity, where the system is placed, it is not mentioned. So, because of this, we can approach this problem in the two ways. First one is method 1. When we don't know where the system is placed, in this case, we can't use the acceleration due to gravity because we don't know where the system is placed. ये space में कहाँ है नहीं पता है. Only the question is telling that 480 Newton upward force is being applied, and this m1 is equal to 20 kg, and the rod mass is 8 kg, and m2 is equal to 12 kg. ये सारी बातें दी हुई, ठीक है. So if we don't use the g value, how can we proceed? We can proceed by find the acceleration in the system because of applied upward force, so that acceleration A is equal to F upon total mass. So F is equal to 480 Newton upon total mass 20 kg plus 8 kg plus 12 kg. This will give 480 upon 20 plus 20, 40 meter per second square, that is 12 meter per second square. So this is the acceleration due to this force only, because we don't know where the system is. Then because of this acceleration, these masses m1, m2 and rod are moving with this acceleration, and because of this acceleration the rod is in the tension. There is a tension in the rod that is acting along the rod like this in the middle. So we can find the tension at the midpoint. At the midpoint, total mass acting is 4 kg of the rod plus 12 kg of mass m2, that is 16 kg. 16 kg is the total mass acting below the midpoint. So we can find the tension in the rod below the midpoint. Tension in the rod below the midpoint of the rod, midpoint of metal rod. So that is T is equal to total mass is 16 kg. 16 kg into acceleration 12 meter per second square. So by multiplication you get 16 to the 32, 16 and 3 9, 190 Newton. So by this method you find the total tension in the rod below the midpoint is 190 Newton. Now can we solve this problem by another way? If you know that this system is placed on the earth, then yes, we can find the solution by assuming that method 2, system is placed on the earth, right? So when we assume that system is on the earth, then in that case, see, this is the mass m1 and there is a rod in between the two, and this is the mass m2. So mass m2 is equal to 12 kg, right, and mass m1 is equal to 20 kg, and rod mass is 8 kg, and upward force applied is 480 Newton, and we have to find the tension below this midpoint, right? So for this, if we divide this rod into two parts, the total mass below this midpoint is equal to 12 plus 4 kg, right? And below above this midpoint, the total mass is 20 plus 4 is equal to 24 kg, right? So this is the arrangement, and when it is placed under the gravity, there is another force acting on the masses or their weight acting downwards. So the net force on the weight total weight is equal to 20 plus 8 plus 12 kg into g. Acceleration due to gravity, that is 20 plus 8 plus 12 into 10 Newton, that is 40 plus 10 is equal to 400 Newton, and this total weight is acting downward and the applied force is acting upward. So there is a net force acting on the system, that is net force F net is equal to 480 Newton minus 400 Newton is equal to 80 Newton upward, right? This is the upward force acting on the system, right? Now because of this net force, there is an acceleration there is an acceleration in the system that can be find. So acceleration is equal to F net upon total weight, total mass, that is equal to 80 upon 40, that is 2 meter per second square. Now we will find the tension T in the rod below the midpoint. So that will be found by tension T in the rod below the midpoint will be given by this mass below the midpoint, that is equal to 12 plus 4 kg into the total acceleration G plus A, that is 16 kg into G, 10 plus 2 meter per second square. So that is equal to 16 into 12 kg meter per second square, that is equal to 192 Newton. So this will be the tension in the rod below the midpoint. So this is the second approach, by assuming that the system is under the gravity of the earth. So I hope that you understand this solution and it may be useful for you. So thank you for watching this video.